Hello and welcome guys. Now in this tutorial we will be implementing linear regression on the real-time data. Okay, so in this project what we will be doing is we will be using advertisement dataset. Okay, and on that advertisement dataset we will be building model and it will tell us what is the sales. Okay, so it's like a sales dataset. So let's get started without wasting time. So the very first thing that we do is we need to import all the libraries. Okay, and before that let's rename the notebook. Okay, so let's import numpy as np, import pandas as pd. Okay, this is what short form we use for these libraries. And after this what we need to do is we need to import our data set. Okay, so let's say data equal to pd.read csv, and if here we need to pass the name. So as we have already uploaded the file here, we just need to pass the file name. If the file is in different places, you just need to pass the path as well. Okay, so after this, so we have loaded the data. Now let's see how it actually look like. Okay, so data.head will show us first 5 rows, and you can see that we have TV column, we have radio column, we have newspaper column, and we have sales column. So this is our target variable is sales, and this is our independent variables. Okay, now let's move ahead and see what is the shape of data that we have. Okay, so basically shape will tell you what is the number of rows. So you can see that we have 200 rows and 4 columns. Okay, now let's see information about the data. Okay, so it will tell us data type and whether it has null or not null. Okay, you can see that for each of the column we have not null count, and then what is the data type. Okay, now let's see what is the descriptive analysis. Okay, so we can do all the descriptive analysis, or you can just do data.describe. It will um, do all of those things for you as well. So you can see that it has number counts, what is the number of rows we have, what is the mean, what is the standard deviation, mean 25 percentile, 50 percentile, max 75 percentile. Okay, so hope using describe we will be able to get some idea about how the data is actually. Okay, you can see that we have standard for sales we have standard deviation of 5. So it should we should be looking at the sales data more often, because the standard deviation which is 5, it shouldn't be 3 times standard deviation of actual standard deviation. So if the standard deviation is 50, then we have to look why that is the case. Okay, for different rows. Now since we have understood the data, now what we have to do is we need to visualize. Okay, and for that we have 2 libraries. One is matplotlib, another is cbond. Okay, let's see what is the use of all those. Okay, so we have imported the library. Now we will first make a pair plot of all the variable present in the data set to visualize which variable are more correlated to sales. Okay, so for that what we use is we use cbond plot. Okay, cbond dot pair plot, and we pass our data and our x variables. Okay, and here we need to pass the name of columns. So to see the name of column, what we do is data dot columns, and it will give us the names. Okay, just copy the names and pass it here. Okay, now we also need to pass y variable, that is our sales. Size should be, let's say, 4, and we need our plot to be scatter. Okay, now plt dot show. Okay, here I guess. Okay, so you can see all of the plots, and with this plot you will be able to see how actually the data is populated over x and y axis. Okay, so on the y-axis we have all the sales, and the x-axis we have all the other variables like TV, radio, newspaper, all of those. Okay, now you can see that this radio and newspaper is populated over all the position of the graph. So you can tell that these 2 columns are not much correlated, but TV you can see that the correlation between sales and TV is very high. You can see that the the if we put the fitted line, you can see that the line will be very accurate. And one more way to find out how much correlation it has. Now you can use heat map. So sns dot heat map data dot core. You can also use cmap, which is y1 g and bu, and we want a node to be true. Okay, now we will be able to clearly identify which column is correlated, which are not. You can see that sales with TV is 90% correlation. Sales with TV, radio and newspaper is 35 and 16 worst correlation. As I told you already, since the data is very diverse and not very linearly correlated, I mean changing on sales value won't, I mean the effect will be very low for radio and newspaper and vice versa. So on changing TV value, the sales will be very high. So that is what we are understanding from these column. So the TV is very correlated with sales, and the radio newspaper not much. Okay, and I mean this is very this is visible from pair plot as well. I mean the correlated ones. And now let's go ahead and perform simple linear regression using TV as our feature variable. Okay, so you remember our formula for linear regression was y equal to c plus m into x mx, right? So here x will be our TV, okay, and m is called as coefficient, and c is our intercept. Okay, so let's define our x and y first. So x will be our data of TV, and y will be our data of sales, since it is our target variable. Okay, so let's create some space. Okay, so we have defined our x and y. Next thing we have to do is we need to perform train test split. So we will perform this by importing train test split from the Sklearn library, and it is usually a good practice to keep 70% of data into train dataset and rest 30% of our test dataset. Okay, so let's do that. Okay, so we have imported train test split. Let's define our x train, x test, y train, and y test. Okay, pass our x and y. Okay, test size will be 0.3 and random state equal to, let's say, 100. Okay, let's run this. Okay, Sklearn. Now what we need to do is, let's see how our x train, okay, how our x train looks like. Okay, this is how our x train look like. Let's see our y train. This is how our y train look like. Now what we need to do is we need to build a linear model. So for that we need to import Statsmodel. Okay, so to perform the linear regression. So for that, import Statsmodel dot API as sm. Okay, so let's import this. So by default the Statsmodel library fits a line on the dataset which passes through the origin, but in order to have an intercept we need to manually use add constant attribute of Statsmodel, and once you have added the constant to our x train dataset, we can go ahead and fit the regression line using ordinary least square attribute of Statsmodel. Other than this, remember in the previous tutorial how we have done, we have created a data frame, and in that we created one column that is intercept with one's value. We can also do that. Okay, so for now let's go ahead with add constant method. So for that, x train sm equal to sm dot add constant. Okay, and here we'll pass our x train. Okay, now we need to fit our regression line using OLS. Okay, so lr equal to sm dot OLS. Here we will pass our y train and our x trains, the latest one. Okay, and then we'll fit so that it will train the model. Now let's see the parameters. Okay, lr dot params. You can see our constant is this tv. TV is 0.05. Okay, now what we will do, we will perform a summary operation list, which will list out all the different parameter of regression line fitted. Okay, so the good thing about this stats model is that it provides a summary about the model, and it will be very easy for us to understand that summary and make use of it, and comprehend what actually need to be done or what not need to be done, or the model is already in a good shape. Print lr dot summary. So you can see how clearly this summary has shown, and we'll discuss about all the things here. Okay, so the only important things we need to be concerned about is the coefficient of significance, which is p-value. You can see that here we have p-value. Okay, this is what we are concerned about. Okay, then we have r squared. Here we have r squared value. Okay, then f statistic and its significance. Okay, this is f statistics. Okay, and its significance. Okay, so let's understand what each of these terms are. Okay, so basically the p-value is a measure of evidence against the null hypothesis. So you remember we have learned about null hypothesis. If not, please go ahead in the statistic playlist and go through the videos about what is null hypothesis and alternative hypothesis. So basically, I mean, this p-value is a measure of evidence against the null hypothesis. In the context of regression analysis, it indicate whether the coefficient of the independent variable in the model are statistically significant or not. So for each independent variable in the model, a p-value is calculated. A small p-value typically should be less than 0.05, or another significance label chosen by researcher. So it indicates that the variable is statistically significant in predicting the dependent variable. As you can see, the value is less than 0.5. So you can say that this particular column is statistically significant. Okay, so if the p-value is small, you can reject the null hypothesis, which suggests that the corresponding coefficient is not equal to 0. Now other thing is r squared. Okay, so r squared is a measure how well the independent variable explain the variation in dependent variable for the given model. So it represents goodness of fit of the model. So r squared ranges from 0 to 1. 0 indicates the model explains none of the variable in the dependent variable, whereas 1 indicates that it explains all the variable goodly, nicely. So in the simplest term, r squared quantifies the proportion of variance in the dependent variable that can explained by the independent variable. A higher r squared value implies a better fit of the model in the data. So we have 816. You can see that it's not a bad model, it's a very good model. Now don't get confused by adjusted r square. So adjusted r square is another parameter that is similar to r squared. So basically how it is different, so the adjusted r square will keep on increasing the number of column. So for now we have added TV. Okay, so in the next tutorial we will be adding other columns also, like radio, newspaper, and you will see that the adjusted r square will increase even if those column doesn't make any sense. You can see that by heat map, the newspaper column doesn't make any sense to the sales. Okay, I mean, they do not correlate basically. So even they do not correlated, we will see the r squared of that particular model, where when we will use TV along with newspaper as an independent variable, we will see that r squared has been decreased, but adjusted r square will keep on increasing. So that's why we not use adjusted r square as a parameter for validating the model. We just use r squared. Okay, now the other matrix is f statistics. Okay, so basically f statistic is used to test the overall significance of regression model. It assesses whether at least one of the independent variable has significant impact on the dependent variable. Okay, so this f statistic is used to determine whether you should reject the null hypothesis. If the f statistics is significant and greater than 1, then it suggests that at least one of the independent variable is significant in predicting the dependent variable. So the f statistics is often used in conjunction of p-value of individual coefficient to make overall inference about model significance. So this is what I mean, all the important metrics we need to consider during analyzing the summary. Okay, and this is what coefficient is. Okay, and this is error. Okay, and this is t-value. Okay, so this is what we understand through this summary. Now you can see that coefficient of TV is 0.05 and with very low p-value. Okay, so the coefficient is statistically significant, so the association is not purely by chance. Okay, so also we have seen that the R squared is 81%, which is explained by TV. So this is like a decent R squared value, as well as F statistics that we have seen. It's like a, you know, very low p value. Okay, so so what we can say is meaning that the model fits statistically significant, and the explained variance isn't purely by chance. Okay, so you can say that this fit is significant. Now let's visualize how well the model fit the data. Okay, so for that we'll use scatter plot. plt.plot xtrain six 948 plus 0.054 into x train, comma r is color. Okay, so now you can see that our like I said, the fit is significant. You can see that the line is also making sense. So let's do some residual analysis to validate assumption of the model, and hence the reliability for inference. So we need to check the error term, which are normally distributed or not, which is in fact one of the major assumption of linear regression, and we will see later on more assumption about linear regression. But for now, let's see the error term. So let us plot the histogram of error term and see how it look like. Okay, so for that, y train pred equal to lr dot predict strain sm. So residual will be y train minus y train pred. Okay, so we have found our residuals. Now let's plot them. Okay, so fig equal to plt dot figure sns dot distribution plot the rest, comma, here we need to define our bin size. So let's say bin size is 15, means 15 histogram will be plotted. Okay, along with the line. So plt dot subtitle font size, let's say 15. White trend prediction, then font size, then plt dot show. Okay, bin, okay, it should be bins, some attribute error. Okay, font size, okay, now you can see that I mean, this is how our error term look like. So you can see that this is normally distributed. Okay, which means that mean is 0. You can see that middle point is 0. So we can say that this is all good, and we can say that our fit is very good. So now let's see the pattern in the residuals. Okay, and for that we need to do the scatter plot again. So plt dot scatter xtrain, comma, residual, and then plt dot show. So we are confident that the model fit isn't by chance and has decent predictive power. So the normality of residual term allows some inference on the coefficient, although the variance of residual increasing with x indicates that there is significant variation that this model is unable to explain. Okay, as you can see, the regression line is pretty good for the fit. Okay, so now let's do prediction on test set. Okay, now that we have a fitted regression line on our training data set, it's time to make some prediction on test set. For this we need to add a constant to x test as well, data like we have did for x train, and then we'll simply go on predicting y values corresponding to x test using the predict attribute of the fitted regression line. Okay, so let's copy this line here from here. Yeah, add constant Okay, here let's rename train with test. Okay, okay, let's see our prediction now. Okay, so you can see that our prediction looks like this. Now let's calculate the root mean squared error as well as mean squared error, and for that we need to import those metrics. So it can be imported from metrics from sklearn library. So let's do that. So from sklearn dot metrics import mean squared error, then same way just copy it, or to score. Okay, now let's print them. Okay, so np.sqrt mean squared error, and we'll pass our y test and y pred. Okay, and then let's check the r squared on the test set. Okay, now you can see that we have our r squared as well as our root mean squared error. Now let's visualize the test set. Okay, so you can see that we have around 80% of accuracy as well as the error is very low. That this is what I mean this metric telling us. Okay, now let's visualize the fit on the test set. Okay, and for that we'll again use scatter plot. Hope you understood the importance of scatter plot now. plt.plot. Okay, I forgot to add 0.054 here. Okay, now you can see that I mean the fit is very good, and you can see that both x and y axis are clearly separable, and the error is very low that we have also seen, which is 2. Okay, now what we will do is, apart from Statsmodel, there is another package, namely Sklearn, that can be used to perform linear regression that we were earlier discussing. Now we will use the linear model library from Sklearn to build the model. Since we have already performed rent split, we don't need to do again. There is one small step that we need to add though. When there is only one single feature, we need to add an additional column that is we have seen in the previous step also, in order for linear regression fit to be performed successfully. Okay, so we'll see that. So before that, first let's copy the code of rent split. Okay, now just rename it so that above variables don't get overwritten. And we need to also change our random state to, let's say, 101. Okay, now we can check the shape of our train set, which is 140. Okay, now let's reshape our X train. Okay, you can see that currently it doesn't have any shape, which means it's like a form of array. Okay, so we need to reshape it to something like data frame, which at least have one column. Okay, it's saying series object has no attribute reshape. Okay, we can do one more thing, that is values dot reshape. Okay, so you can see that the reshape has been done. Now you will see that the shape has been changed to 1. Okay, so let's print the shape of all the set. Okay, now we will we will import our linear regression from Sklearn library. Okay, dot linear model import linear regression. Okay, now we'll call the instance. Now we'll fit our model lm dot. Okay, now the fit has been done. You can see our linear regression model has been created and it is trained. Now let's see the intercept and the coefficient. To see that, we need to do lm dot intercept, and then for coefficient it's just COEF. Okay, now you can see we have our intercept and coefficient. So you remember, this is the actual value that we were getting in the earlier way of doing from stats model, you remember, right? So the number that we were multiplying 6.87 and 0.5, you will see here, yeah, so it was 6.9 and 0.54, which is closely similar to what we were getting. So yeah, I mean there is some little bit different, and those error cannot be definable. So yeah, I mean hope you have got understood what is the difference between linear regression with stats model, linear regression with Sklearn, and how the implementation differs. And also the reason could be the version that we are currently using, they might differ, and for that reason only there is slight difference, but anyway the value should be around same. And hope you guys have understood how to implement these different type of method with simple method as well as with library. And now I think you have clear understanding of how linear regression works. And in the next tutorial we will be looking multiple linear regression, where instead of just one column we will be using multiple column, and all the things will be almost same. There will be nothing much drastic change. There must be a few lines of change that we will be doing, and rest of all the thing will be same. And yeah, hope you guys have learned learn this linear regression algorithm clearly. And for if you have any question, you can just comment below. And for this notebook I will be uploading it into GitHub, and from there you can download, and you can see, play around with it. So yeah, thank you so much. Hope you guys have liked. Please do subscribe, like, and do comment for any question. Thank you.